Green chemistry is the design of safer molecules, which are safer for biological systems, ecosystems, and human health. This is Switzer Network News.
Every day in the United States, we are producing or importing about 74 billion pounds of industrial chemicals, excluding fuels, excluding pharmaceuticals, excluding pesticides, excluding food additives, just industrial chemicals that are used in consumer products, commercial products, and industrial processes. And if you imagine 74 billion pounds, if you imagine that if you translate it to gallons of water, it would fill enough of the big tanker trucks that pass you on the freeway, the big gasoline tanker trucks, to stretch 10,000 miles if you placed them end to end. That's daily production and importation of industrial chemicals. All of that material, in one way or another, comes in contact with people at some point in its life cycle and enters ecosystems at some point. Much of it is toxic to biological and ecological systems, and the consequences, as we have seen global chemical production rolling out over the last 50 years or so, have been extraordinary in many ways. We're expecting global chemical production to double in the next 24 years and every 24 years thereafter. Looking just specifically within the state of California, for example, we have found that about 3/4 of the hazardous materials or hazardous waste sites in the state are leaking directly into groundwater. It's going to take 400 years for the state of California to clean up existing hazardous waste sites. Nationally, the US EPA is expecting the need for 600 new hazardous waste sites every month of every year projected out to year 2033 on our current trajectory. Half of the substances at existing sites are known carcinogens and or known teratogens, that is, they cause birth defects. Those materials are leaking into groundwater. Every year in the US, we have about 60,000 premature deaths from occupational exposures to industrial chemicals. We've identified upwards of 300 industrial chemicals in human blood and now in umbilical cord blood. I mean, these are snapshots of the nature of the problem. Hundreds of chemicals identified in ecosystems worldwide now. So those are public health problems. We're seeing in some cases in some of the breast milk studies, industrial chemicals with a doubling time in terms of concentration of 5 years. And so our argument is that given the pace of chemical production, given the scale of chemical production, and given these health and environmental problems that we're facing, that we have to embrace green chemistry. We have to design chemicals at the beginning to be safer. We can't put them in waste sites. We can't release them into workplaces and so forth. We have to design safer molecules, and it's a huge, huge scientific challenge. Green chemistry is an essential element of what we need to deliver to future generations. Just as we're doing our very best now to deliver cleaner sources of energy, despite all of the setbacks, green chemistry needs to stand side by side with that, and needs to be part of an environmental social ethic about how we produce and design materials and products, where they end up going on the earth, who's affected, and who benefits. Similar to the problem of clean energy sources, green chemistry is really a way of thinking about how we approach our science challenges, the design of materials and products beyond our generation, and thinking about multiple future generations and the kinds of problems that we're delivering to them or the solutions that we're providing to them.
For more information about the work of Switzer Fellow Michael Wilson, please visit this website. This is Switzer Network News.